Good morning, good afternoon to everyone. Thank you very much for joining this TDL's third webinar of 2025. We're going to be looking at Edge and 6G. Primarily, we're going to be looking at cybersecurity challenges. For the participants, thank you for joining. If you have questions, please put them in the chat and we will make sure that Claire, who is our moderator today, Claire Vishik, our strategic advisor, will bring them up if appropriate, and I'm sure they will be appropriate. So with that, I'd like to hand over to Claire, who can introduce the rest of the panel and get our session going.
Thank you very much, David. I am delighted to be here to discuss this important topic, something that was on the mind of people working in telecommunications for decades in different ways. We have distinguished panelists on board today. Dario Sabella, who is VP for Technology and Standards in xFlow Research. Ioannis Kronitiris, who is a senior researcher in Huawei. And finally, Alex Reznik, principal global architect for Telco Edge in several key companies in this area. So with this, let me make a 1-minute introduction to the topic as I see it, and then we will move to the discussion. Almost 25 years ago, I joined AT&T Labs, and the first meeting I had in my first day was with the CTO of the company at the time, who was talking about his vision for intelligent network and edge. And you should remember that it was very, very early time in the wireless architecture and communications, but still the vision was that there will be more intelligence in the network. There will be an edge that is functional, that is truly connected to the network. Since then, I participated in dozens of projects that were bringing forth this vision, including about 10 years ago, near data processing and things of this nature. And now we are well on a path with standards being developed, with architectures being tested to really enable the edge. And it is clear that cybersecurity is one of the key areas to ensure that we go past prototyping, we go past R&D to a large-scale deployment. Potentially, we are here witnessing something that will enable killer applications for 6G. And this is why this discussion is so important. It is on everyone's mind. Everyone is looking into this area. The cybersecurity areas and topics are not overlooked this time. And luckily for this conversation, we have great experts to conduct this discussion. With this, I will turn it over to the experts, asking each of you to introduce the most important cybersecurity challenges in multi-access edge computing, and your reason for elevating specific challenges. Please link what you are talking about to 6G opportunities where appropriate. And each of you has 2 minutes. I will have Dario start the discussion this time. Please, Dario, what are your views?
Thank you, Claire. Yes, thank you for having me, and hello everybody. So yes, so let me start just to introduce myself and my perspective. I'm Dario Sabella. Here I'm talking, of course, working with xFlow Research as a VP and leading the standardization and engagement team for open source and industrial groups. Also, I'm a country manager as a managing director of NextG Cloud, which is a new legal entity based in Italy for the European market. But here I'm talking also actually especially on behalf of a standardization group. So I would like to bring the point of view of the standardization as a chairman of ETSI MEC. And what's a MEC about? You mentioned the multi-access edge computing. So let's go to the point, since I have just little time, but just want to focus on the challenge. Let's start honestly from the problem. We have a lot of security problems. The security is, I say always, it's like a universe. When we talk about cloud security, but more on edge security is still a big issue and still is a galaxy. Okay, edge security. When talking about what honestly needs to be done in the perspective of standardization, still this is a huge space, and maybe it's the solar system, but still something that need to be explored. Why? Because we have old problems and new problems, and maybe sometimes we have like in a toolbox something which can be still a solution that can be addressed with an old tool that we have in our hands, but sometimes we have to investigate if we need to solve our security issues for the edge cloud with new tools, and probably also the problem is about interoperability. So the only thing that matters for me when it comes to standardization is enabling interoperability. So talking about edge security, the problem is mutual trust from architecture and infrastructure and applications and then workloads. Mutual trust, why? Because edge computing is a heterogeneous ecosystem, end-to-end, provided by different stakeholders, and the infrastructure, the underlying infrastructure being virtualized, is hosting some workload which is potentially untrusted. And vice versa, an application can work on an infrastructure which is owned by a third party and can consider infrastructure itself as untrusted from the application perspective. So really, it's a mutual trust problem and a need for interoperability. So this is where, as a standard body, ETSI MEC is working since 2021 with a humble and honest approach, trying to reuse the tools when they are pertinent, to not reinvent the wheel, but to understand if we need some tailored solutions for the edge. And we are starting after a report, some informative specification. Now we are moving to normative work to do the serious standardization work. So this is just in a nutshell my point of view. I'm very happy to discuss and debate on various topics, also in perspective, thinking about 6G as a provocative term. Who knows if we really need 6G? If something called 6G will be there, maybe we have to now think about how to protect our infrastructure and our applications for the future evolution of the cloud. So that will be also the challenge.
Thank you very much, Dario. That's a great perspective that you presented, and you are very well positioned to expose it in this way. Alex, your turn now. What are your views?
Sure. So it's always good to follow Dario because he hits on so many points. I can just kind of I can say I agree with everything that he said, but it also gives me the ability to just pick a couple of things that highlight them. I was very happy to see the work that ETSI MEC has done on their security report and kind of focusing in on some very important areas of platforms security, right? And how do you actually enable trust at the edge? And in fact, I've recently spent time and participating in ORAN's, what they call the Next Generation Research Group, which is the 6G research group. We should have a report coming out on similar topics with a viewpoint towards 6G. So I wanted to highlight that. So, but what I want to do is I want to kind of take that and zero it down and say, what are the things that I'm seeing around the edge, and especially looking forward to 6G that to me present particular challenges. And they have to do with really thinking about this notion of trust and looking at things that we normally assume are trusted, but yet suddenly become untrusted in these contexts. And I'm going to highlight two. One of them is physical infrastructure, right? And so I think for most people, when they think of their servers that go into their data center, or the servers or the physical infrastructure that they use from their cloud provider, they assume an implicit stance of trust. It's either in my secure environment or, Amazon, Google, Microsoft have secured that. That's their responsibility, right? That's their part of the shared responsibility model. As soon as you start talking about the edge, in most cases, that is no longer true, right? As you go to your edge deployment, you can no longer just implicitly assume that an infrastructure is trusted. And when you have an untrusted infrastructure, it can do some very, very serious damage, especially in environments that we're seeing today at the edge, and which will increase going into 6G, where we are increasingly turning to automated zero-touch deployment methods. Well, a device shows up on your network that you're not seeing, claims to be the new server that your automation software needs to deploy your proprietary software onto. And so today, in most automation frameworks, you're quite likely to just go ahead and deploy it. That could be somebody's device that has now gone and taken that image and is going to walk out of that unsecure edge facility, right? Very, very kind of a simple attack model, and yet they're walking away with something that's quite valuable to you because it's an image that has some automated boot scripts, probably includes some key matter. So there's a lot of value in what potential value in what just happened. You can no longer assume that trust environment. Now, the good news is, when we look at the industry, the tools are there to extend the notion of trust to hardware infrastructure at the edge. The bad news is, as an industry, and I've kind of seen this working with folks over the last couple of years, we really don't know how to properly use those tools. And in fact, in many cases, we don't even think about the fact that we need to really put a lot of thought into this aspect of the problem until we're kind of post factum, right? And there is a lot of aspects to it, including a lack of standardization, a lack of kind of best practices. There are some regulatory issues, right? It all kind of comes down to the fact that as an industry, we've never really had to deal with this kind of a massive edge, but we are beginning to deal with it now, and it'll certainly be much, much bigger when we talk about 6G. That's one area. The second point that I want to highlight is, when I think about 6G and I kind of think about it, well, what is going to be drastically different in this thing that we're going to call 6G? To me, it's the likely prevalence of AI all over the place, right? So there's going to be AI all over the place. Well, what does it actually mean to trust and understand your model? And that's a question that there's a lot of work being done on right now. But I think, again, as not just as a telecom industry, but as a wider technology group of industries, we don't necessarily understand it. And it's both a data issue, right? Because you can have the most trusted and secure training process, but if you don't trust that training data, then you have a problem. It's a problem of potentially where the training is going to be done. How do you trust the model that has been delivered to you at the end of the day? Can you go back if you have an issue and actually validate that the model was trained using appropriate data? Has the data been stored somewhere? And is there a notion of immutability to that data, right? That suddenly becomes a very, very difficult problem, because obviously if you're using LLMs as part of your overall AI approach, you can't ask that question of the LLM. But if you can potentially ask it of the data that was used in your RAG to train, to specialize your model to your specific needs. So those are two specific areas that I'm actually very interested in, and I wanted to highlight.
Thank you, Alex. Very interesting views. Ioannis, what do you think?
Yeah. Okay. I'm glad I'm third, because I already got a lot of challenging ideas. I mean, I was also going to mention the trust as the biggest challenge to be addressed. Yeah. But it is much more complicated topic than maybe we think, because first of all, it is even very difficult to define what is trust. I think a lot of people are trying to define trust and trustworthiness, and it's not so easy. And maybe later for standardization, if we discuss, this is an effort happening there that still has not given a lot of fruit. So the difficulty to define trust is also the difficulty to find tools to solve it. But in general, I think we will all agree that building and establishing mutual trust is really necessary for such environment as MEC. I'm having a lot of interesting discussions in mobility applications, for example, because I participate in 5GAA, where we discuss this task offloading from a vehicle to the MEC, for example. This is very, very interesting application to see the challenge of establishing trust, because it's a very dynamic environment. It includes mobility, it includes safety requirements, it includes low latency requirements, everything. But here, I think this kind of applications, first of all, give us the importance of assessing trust, establishing trust in a very dynamic environment where you need to continuously assess the trustworthiness of the other end, of the other party, because you can never establish trust and then rest assured that it will stay forever. So the dynamic nature, I think, is quite important. And let's also mention, to conclude, maybe privacy also as a second challenge, so that we don't only focus on trust. Because, for example, in the example I just mentioned, mobility, offloading tasks, for example, but also making sure the service continuity as you move down the street, for example, with your vehicle. The privacy aspects are becoming very interesting, because the service migration trajectory, for example, can overlap a lot with the user movement. So how do you guarantee trust? So this is more going into the direction of protecting privacy and private data, sensitive data, as they are transferred from one environment to another. But then at the end, you again can reduce the problem to trust, maybe. So that is just very, very briefly some challenges from my side.
An excellent overview. Thank you. Just one more question to one of the panelists. Having worked on a number of large-scale initiatives that look at cybersecurity and trustworthiness and trust challenges in various environments, such as NIST cyber physical systems or on FCC Resilience Council, I can tell you that it's very difficult to move away from generic challenges, generic attacks that apply to all of IT, to something that is specific to Mac, something that is specific, let's say, to 5G, something that's specific or will be specific to 6G when it's finally defined to a sufficient degree. What do you think are a couple of specific challenges, not IT generic, that apply to everything that Mac is going to experience, in your opinion? And Dario, you are the best positioned to answer this.
Thank you so much, Claire. This is indeed very much important. Let's focus. Okay, starting from what is more specific on the edge. Of course, when you talk with people, everybody will tell you their narrative. The edge is here at the device, the edge is on premise, the edge is in the network edge, is in the remote cloud, whatever, right? So actually, from a standardization perspective, this is actually, let's say, a deployment choice. But moving to the edge whenever is really closer to the client application. Actually, the point is that we are to deal with some infrastructure which is, for one hand, on a different trust domain than the communication network. This is in the general case. Sometimes the edge is owned and managed by the operator, the 5G operator, but also in 3GPP specifications, we know edge computing service provider, ECSP, is in a different trust domain outside the PLMN network. And this can be another guy, another entity which is managing the edge infrastructure. A third entity is application service provider, ASP. It's another stakeholder. So you see the system is very heterogeneous because there are different stakeholders. And then coming back to my problem of mutual trust, this is really the fact that you have edge infrastructure owned by a certain ECSP entity and application workload running at the edge owned by the ASP. Now we have the issue, which can be also typical of other kind of workloads and applications. But the Mac application has to deal with different issues at the edge, including mobility, as Ioannis explained. And you may have typical problems that we've studied, for example, for the Mac in the GR41, which was a working item where we started with a list of use cases and typical key issues derived from the Mac, and trying to see what is present in the literature as existing problems and available solutions for the Mac, and then deriving also possible solutions and recommendation for the normative work. So I will not maybe explain detail or everything is done in that specification. So you may have a look to the ETSI MEC 041, which is a study on Mac security. But just to give you some examples of key issues. One is the, for example, stolen Mac application access token. And then in this case, one of the solutions is, of course, to exploit existing solutions like using OAuth 2.0 and mutual TLS authentication, and also limiting certificates-bound access tokens. But you may have also issues like compromised Mac application in the infrastructure. So you need to verify the provenance of Mac applications throughout all the life cycle, and maybe maybe a solution can be using a sort of cryptographic attestation back from the root of trust, the hardware, and then up to the firmware, the bootloader, the kernel, and the virtualized infrastructure up to the software. And this has to be also supported by the MEC orchestrator in the edge infrastructure. More widely, you may have some security issues related to simply managing of the data in the MEC platform and between the other MEC entities of the system. And then you may need something also for compliancy, like what we call in MEC SMM, Security Monitoring and Management. It's a system, actually a sort of variant of, there is a sort of SMM also for NFV environments, but more closely distributed and in the MEC infrastructure that can provide a sort of security monitoring features for data storage, for analytics, for policy storage, and profiling different security levels. So these are also solutions that can be partially reused from the literature, but it is to be tailored to the needs of the edge, and especially to protect the workload there. There is a new trend of talking about, of course, we know now that we are moving from the traditional cloud and AI, also with new mature models, the industry is now understanding that we can move progressively to edge AI, and processing data where this is generated creates a lot of issues for compliance, for GDPR, for usage of the data also from the users. So actually security there at the edge needs also to comply with different rules and different regulation domains in different countries. So also this kind of policies needs to be adapted where the MEC host is instantiated. And this is also another problem that maybe touches the other points from the other speakers. So just to give you some examples, and now we have a new working items in ETSI MEC dealing with specific aspects. One is SMM, as I mentioned. The MEC 62 is a work item studying exactly this new component that can oversee all the monitoring and logging for the security purposes in MEC. And also we are studying actually it's a new work item, it's a normative work on API gateway for client applications. This is also a major risk when starting to access to the system from the client. You need also to make sure that all security aspects are properly considered. And now, of course, there are proprietary solutions and also open source references for the API gateways, but maybe now the market is more mature to consider basic guidelines to define what can be needed to standardize for the API gateway, especially from a security perspective, which, as I said, it's a critical issue also in perspective. So this is just my short list of few use cases, just to give you the point. You may have a look at the GR41 for more extensive list of MEC specific security issues and solutions.
Thank you, Dario. Your short list is a full basket of sometimes very serious, sometimes tractable areas of cybersecurity. Certainly, both researchers, implementers, and standards writers, standards technologists will have their heads inclined to try to resolve them, and their hands full in trying to find the solutions to some of these very complicated issues. Let's move to the solutions. It's a good transition from here. A lot of work in this area has been exploratory over the decades. The one that I mentioned several times, near data processing in conjunction with the networks, has a very easy premise. More than half of the cycle spent on data processing is for data transfer. So it's a no-brainer that you process data, if possible, closer to the source. Great prototypes were created, wonderful theories were developed, not least by several groups at the we never moved seriously past the prototypes and a number of sometimes excellent research papers. And so the next question is, what solutions will determine the success of the implementation of the Mac architectures? And what are the killer applications for Mac, especially in what we know at this point about 6G context? I think, Ioannis, that's a good question for you. Would you like to start?
Yeah, so if I understand right, the question you're asking, like more concrete solutions. And I wanted to actually make a bridge from what Dario said before, because I think he also pointed to the direction of what kind of solutions we want to develop. And I think given one of the characteristic, like we said, in Edge is these tasks and services that are dynamically scale and move. So I think the most important thing is to extend our solutions to be to offer dynamic assessment of the runtime verification of the service and the software running. So we need solutions like runtime attestation. I think this is quite basic and important solution that we need to develop. If we want to support also zero trust solutions and requirements, this runtime attestation can ensure continuous validation of the system. But because a lot of discussion before was also touching on AI, I think this is where, for example, a completely open challenge to build new technologies and tools that offer not only remote runtime attestation, but also composable attestation, which is when like a service is decomposed in different smaller parts that are run in different places in the network. How can they offer a kind of assurance for the service by composing different evidence from different parts of the service graph, let's call it more formally. And at the end, I think also collecting, a third point would be collecting this kind of evidence and turning it to trustworthiness value. So let's call it a quantification of trustworthiness problem. Calls for tools, calls for solutions, calls for technologies that we currently don't really have developed. So I would like to, or they are being developed now, but they don't exist off the shelf. Yeah. So I wanted to just point to 3 different technological solutions, if you allow me this, and then pass it to the next panelist. But again, these are kind of open research problems at the moment, right?
Thank you very much. Yeah, those are at least 2 of them are, in my opinion, among the most important research areas in this space. What do you think are the applications that yield themselves the best to the Mac architectures? Alex, what do you think? Where do you think Mac is going to flourish?
Sure. So I'll say we kind of have a killer application for the edge in general and Mac specifically already, and it's called inferencing, right? It's just that inferencing is, let's say, not an application, but it's a component of a lot of and ever increasing number of services that we do. But if we kind of take that as an anchor and start thinking about where there are going to be, where is inferencing at the edge going to be extremely important, right? We start landing, well, there's the thing that we already know, which is video processing, right? I mean, there's processing, meaning inferencing, because a lot of the time, even if it's not you know deep neural nets, it's ML AI based inferencing that is already going on at the edge. That's driving a lot of systems. So that's one area. The other area is as people increasingly look into the space of agentic AI, right? So AI that is able to take very high level direction from a user and pull in a number of different agents, right? So a number of different AI agents, figure out how to structure a sequence of steps to achieve that goal, and then achieve it. When you're talking about that level of automation that is interacting with the real world, a lot of those steps have to run at the edge. And again, in most cases, what's running at the edge is inferencing. Right. So if we take those things and we start thinking about, well, what are some of the specific areas where this might be extremely, extremely relevant, especially for MEC, because you also need to bring in that connectivity aspect. I know Ioannis already mentioned the work that he's doing in 5G AA and vehicular automation. I think it's going to be critical there. Another area that I'm personally really excited about for telcos, for example, is wearables. And the reason I'm excited about wearables is because these are necessarily connected devices. And these are devices where the processing is not really subject to Moore's law, even if you believe that Moore's law will remain viable for the foreseeable future. You can't dissipate that much power on a wearable. You're going to burn the user. So there's a much harder limitation of processing power within the wearable, right? The way we solve it today is we bootstrap it to a device like our phone. But the reality is, you know, ultimately there are use cases where you'd like to take that phone out of the equation. You'd like the wearable to be an independent device. Well, what does it mean for all the processing that you can't do there? It has to happen at the network edge, right? So if I think about smart glasses that are able to operate without a phone, right, a lot of the processing has to now be pushed out into something like MEC. And of course, that, again, if you think about whether it's vehicular automation and wearables, and you think about the kind of processing that they're going to be doing, it brings to the forefront a whole new set of security challenges that are, I'm going to go back to something that you said, Claire, right? Clearly different from what is a traditional IT security challenge, right? That there's a ways to attack these systems that, right? So there's attack vectors that would be kind of pointless for IT attacks because they wouldn't do any significant damage to a traditional IT system. And so, right, that when you start thinking about that, it's a set of use cases for the MEC, but it's also a set of completely non-IT security challenges that we need to start worrying about.
Thank you. That's an excellent answer. Let's move to standards and what really needs to be done in order to enable this area. It has become reality today that a lot of areas of computing are developing prior to standards, with sometimes open source taking the role of standards just because of the speed of the development of new technology versus the speed of standardization. But in everything that's connected to the infrastructure, especially even if the connection is indirect to the telecommunications infrastructure, because of the scale because of the need for interoperability. It is more like standards. So when we're talking about Mac, especially in the emerging 6G context, what do you think is the role of standardization? What do you think are the main gaps, and how and when are they going to be compensated for? Dario, that question is made for you.
Yeah, it's, I will say, a very much expected question, and I have to say also the big elephant in the room. I want to be also quite clear, not escape the question, but also very honest on what should be the answer, especially from a standardization point of view. So here, of course, I'm bringing just, let's say, my interpretation, my view, and also, let's say, not the company view, but just what I believe from as a chairman of the standardization body, what would be pertinent to be standardized, because I want to, let's say, clarify at least we should also avoid, I say as a standard guy, we should avoid to fall into the temptation to standardize everything. So if something makes no sense, is the chairman telling you, let's not do that. We just don't need to create yet another standard, new specifications, just a paper and paper, which is useless and not used by anybody. So I'm telling also, not because I'm lazy, but because I care more about the value we create. So just to clarify as a caveat, whatever is what you do in the standardization body, that should create value and open the market. Whenever you define something in standardization, you kind of oblige people to use this kind of same feature or parameter or message, and this obliging everybody to do that. If there is no consensus on products and this is actually closing the market, that will be the opposite effect. You don't want to create this. You instead want to open the market and only allow interoperability. So the keyword, sorry for stressing this again, but really genuinely, not only just the MEC standard, but every standard should be used to enable interoperability when it comes to letting two guys to talk each other with the same language, and then interoperability for universal, for example, API consumption, that can be really needed and welcomed by the industry. Of course, you are just doing damages. Having said that, so you can understand, you bring 6G on the table, and of course, nobody of us has the crystal ball. I cannot predict the future. I cannot sell you my truth or just what I believe. You can have your opinion. Every opinion is equally respectable. Of course, there are companies shaping their view on what will be the 6G. And there will be also March 3GPP workshop. I will be also there doing some networking with the people about the 6G. It's okay, good. We are progressively moving to let's say the industry is progressively moving to more serious discussions on that. But of course, there is also the even respectable doubt: do we really need for 6G? So we have to understand if we already have what we have now in the 5G infrastructure. And this is also a major concern from service provider. And to be honest, they also are right. They want to see revenues and monetize the current networks. So the good news is MEC is not in this debate. MEC, as per the acronym, is multi-access edge computing, not just mobile edge computing. Alex, as a former chairman before me, knows very well that back in 2017, I guess, there was a decision, not just marketing purposes, to change, keeping the acronym MEC toward multi-access edge computing. This was reflecting the industry need to not limit to the cellular network, but also to any kind of access technologies. So in this sense, I can tell you, and then I'm happy because it's a relief for me, have a lot of responsibility less for the MEC chairman. MEC is access agnostic. So really, in certain sense, I don't care what exactly will be 6G. Because it's not up to us to design the 6G infrastructure. I need to work also in perspective, understand what can be, what can look like the evolution toward the 6G, and then make something put in place to support the evolution of future cloud systems, including communication and computation convergence, and the trend of putting AI everywhere. There is a quite, let's say, widely accepted opinion that everywhere there will be AI at every level, from the device to the RAN, to the edge, to the core, and every level of the protocol stack, supporting machine learning from the radio level to up to the upper layers, and also management and automation, as mentioned by Alex. So really, there are some key enablers which are impacting strongly on the infrastructure. Yes, there is a need to follow this evolution, and really the goal of MEC is still the same, I guess, because actually we are targeting instead the exposure of information for the application developers and content providers at the edge of the network. So exploiting the data there locally. And there are still challenges there. And as long as we move forward, and there will be so an infrastructure that will be even more complicated, the real challenge will be to simplify to the consumer this complexity. That's for me the main challenge, because the network is going to be more complex. This is actually something that we cannot even manage as humans. It will be automatically configured and managed by also AI at many levels. And we need really to simplify this kind of complexity to make it more consumable and usable. Actually, the value stays there. There is an acronym, sorry for that, Network as a Service, and NaaS, but it's really also a major priority for service providers to expose the capabilities and the added value from the network up to the application level. Application developers don't care about 5G, 6G, whatever, and whatsoever, any specifications, they don't read at all the standards. So for me, you are bringing also on the table correctly open source. Yes, for me, open source in MEC, I can tell you, is a major priority. Also in the MEC phase 4, we are establishing a number of special task force. We are collaborating with open source projects in Camara. I was the first one in MEC establishing with the Edge working group in Camara project, a collaboration, and also with OpenCapif as an open source community, and SDG in ETSI, TerraFlow SDN, another open source community we started years ago with Akraino in Linux Foundation. Really now the software is driven by open source communities becoming more serious. It's an asset, and our goal is of course to serve application developers, and sometimes also open source projects can be a driver for that, and we are working in collaboration with them really to accelerate and facilitate the adoption. This is also from a security perspective needs to be considered, but in general I believe also I hope this can clarify the limited scope of the standard. We just are there to serve the industry and not just over engineer everything, but collaborate with the open source communities. That's for sure a priority for us.
Thank you. And it's great that the standardization community is showing the open mind of making their activity a translation and speed up activity in the technology area, rather than an objective to create as many standards as possible, which has been the goal in many areas, especially telecommunications, for many years. We are close to the end of this discussion. So I would like to ask each of you in maximum 2 sentences to provide your concluding remarks, with the focus on what do you think MEC will be in 18 months, and what do you think are the main gaps that will need to be resolved for the success. Ioannis, please start.
Okay, just as a concluding remark, like highlighting the points that were also discussed heavily this 1 hour. I think continuous authorizations and authentication should be a big topic to capture the fact that trust states and for actors must be continuously evaluated. And I think these trusted computing technologies and solutions can offer a lot of answers. If we address this dynamic aspect of trust, utilizing this kind of technologies, addressing these challenges that we mentioned today, I think we have a very big chance to build systems, make technologies and systems and platforms in the future that address, offer a trusted environment to build applications. I think AI will definitely dominate some of these applications, mobility also. Another big topic, so and maybe overall 6G services and how they come together. I think these are definitely going to take a lot of our attention in the next 18 months.
Thank you. Alex, what do you think are the main gaps we need to close in the next 18 months as concluding remarks in 2 sentences?
I'll say this. So if you're talking about the next 18 months, so fairly near term, we haven't talked about the business side of MEC, but I think that's been an ongoing puzzle which the industry has partly figured out, but not completely. And so the more we can figure out the business, the economics of how to go to market in the next 18 months, the more successful we're going to be, because that's going to define outcomes, very specific outcomes that the industry is going to want to focus on, and that's going to drive a lot of the near-term solutioning, right? Because I think for that, well, I know that we've got the tools, right? We need to figure out how to do those systems right, and that needs to be driven by the business imperatives, right? And then there's the longer-term things that we talked about a lot here, which is the role of standards, what 6G is going to bring. But that to me is beyond the 18 months horizon.
Yeah, it's impossible to disagree with the need for the business approach to the new technologies, especially something like MEC. Excellent point. Thank you. Dario, what are your 2 sentences for the next 18 months?
I see we have to be a little patient, because sometimes people MEC is there since a lot of time, and people was waiting for the virtualization moving from 4G to 5G. Now, actually, we are seeing the industry, as I said at the beginning, progressively understanding that actually real value can also be at the edge. So far, we have seen a lot of, let's say, slow adoption because of still concerns on costs. So linking to what Alex said, if of course an industry decision maker is not taking any decision, is because they don't see maybe value or clarity about revenues compared to certain costs. The costs are certain, the revenue not. So actually now I can see that I see some signs of progressive maturity, for example, of AI with the reduced workload. This can be also manageable at the edge. This is where we are pushing a lot. I see a lot of increasing interest, serious now on AI. Still, this is not a mature market, but we see value on edge AI. I believe this will be a business unlocker. When it comes to standardization, we have to be also a little bit forward-looking and think about what we build now that will last for years. And this is a challenge, having in mind to not over-standardize everything, as I said, just to summarize my takeaway messages, and keeping in mind that let's say the North Star, the polar star, which is interoperability, just to accompany and support the market for interoperability in this sense. So in this sense, also working on testing and automation. This will be also a major effort for MEC together with the engagement with open source. And of course, it depends on business decision. As I say, always the standard is contribution driven, and this has to come from real working solutions, and that would be one measure will bring more clarity as a let's say example of a reference implementation that would be possibly also driven to standardization. That would be also and we are there to support, just not pushing that, but following the market needs. That's my attitude as always.
Thank you. Thank you very much for those excellent concluding remarks. This concludes our discussion. I would like to thank our distinguished panelists. But before we adjourn, we have a question that I would like to answer. The question is, what can we do to resolve the performance and security trade-off in 6G and perhaps in MEC as well? Ioannis, what is your view of what you think will need to be done as a very quick answer with regard to this performance to security trade-off?
Yes, so I think, like I said, I think we talked a lot about, for example, in automotive application where performance is a very big topic, and I think it is achievable. I think it is already part of the requirement. Security is not putting overhead that should not, to block the applications. But from the experimental evaluation that I have seen, it's already achieving very good overhead performance, like performance that doesn't create a lot of overhead. So from my side, I'm not so much worried about it.
Thank you. I heard this view before, and I don't disagree. Well, again, huge thanks to our distinguished panelists. This discussion will be recorded and will be available online. Thank you also to the Trust in Digital Life, TDL Association, for organizing this discussion. I hope to see these panelists in future discussions. We have discussions at least every other week. And I will pass it on to David Goodman for final remarks.
Thank you, Claire. And my thanks also to Ioannis, Dario, and Alex, and Claire as moderator for holding this session. Thank you to the participants, to the attendees. The next event will be not in 2 weeks, but more like in 4 weeks, on the 20th of March, on the subject of cybersecurity skills and recruitment, understanding the skills shortage. Extremely relevant subject, and the moderator for that will be Steve Purser. Information will be on the website.